Hello again, Robert Smitty Smith, back once more. And now for all you advisors, TAs, Ricky Racers, I'm going to give you a quick overview of EFI, electronic fuel injection. For FSAE programs, for years now, carburetors have been looked down upon, and rightly so, because they're very crude instruments in controlling emissions and maximizing performance, both mileage and horsepower output. So the standard of today is electronic fuel injection, and if you've never been around it or familiar, I'm going to give you a basic overview that you need to know. If you're Ricky Racers, this is the wave of the future. I have two reference books, paperback, relatively inexpensive. For FSAE, Motorcycle Fuel Injection Handbook by Alan Wade. Very, very good, because guess what? Motorcycle fuel injection systems are generally less sophisticated than automotive fuel injection systems. Now, for a more complete view of mapping and all the things involved, then this is a book I acquired recently, High Performance Fuel Injected Systems, written by Greg Banish. And these kind of books, rather than analytical books, are what programs need, because these are really how to make things happen book rather than theoretical principle book. I'm sure you can find these on Amazon, eBay, wherever. Now, first and foremost, there are tons of acronyms, especially when dealing with electronic fuel injection. And manufacturers sometimes use their own acronyms. You need to become familiar with what means what. You'll see ECU, electronic computerized management box, or CMU, computer management unit, something like that. It means the same thing. Get used to the acronyms. There are tons of them. Now, the first thing I try to get my students to memorize and understand and use is this here. This is for gasoline, 0.5 pound per horsepower per hour. When we're talking about electronic fuel injection rating, this directly correlates to the injector ratings. Injectors are rated in pounds. You'll have a 35-pound injector. You will have a 25-pound injector. You will have a 20-pound projector. That means that in 1 hour of time, it will pass that much gasoline. So, if you have a 35-pound injector, it will support 70 horsepower. If you have a 4-cylinder engine, it will support 280 horsepower. Just that simple. Injectors must be matched to the horsepower output. And injector types, there are basically two. They're easily identified. There's the SAT with a period. That is short for saturated. Then there's the P&H type injector. All right, here's what that means. A saturated type injector gets a small limited current, usually in the 1.1 to 0.7 amp range, and that current flows until the coil is saturated and it holds the injector open. Here I have a little chart here, open time. So basically a saturated type injector will apply power, that power will saturate, it will open. Over time, it takes a little bit of time for it to get fully open. Then it holds it open for whatever the computer says to hold it open, and then it closes with the help of internal spring, tension, and fuel pressure, and it shuts off. And then time passes, and then the computer tells it to open again. On a P&H type injector, it flows more current. Initially, it flows 4 amps. Then it cuts back to 1 amp to hold it. It's opening, if you plotted this on an oscilloscope, you would see that it opens in a much faster ramp than the saturated type. Mainly, it's got more power to open it, and then it cuts back to hold it open, and then it falls back and closes. Now, they're easily identified by all you have to do is measure the resistance of the coils in the injector. If it's 2.5 to 4 ohms, it's a P&H. If it's a saturated type, it'll be 13 to 18 ohms, and you know what you're dealing with. P&H are high performance types, more expensive. A lot of times you'll only see saturated, especially in motorcycles. Now here, you see the ramp, you can see why this is a higher performance type. It opens quicker, so therefore it can hold open longer over a given length of time. There's a certain lag in a saturated. Now, when we say we fire the injector, we just means we apply power, the injector opens, and then fuel flows. So, firing strategies. There are 3 basic types. There's batch firing, there's bank firing, there's sequential firing. Automobiles, for emission reasons, performance reasons, fuel mileage reasons, all reasons, sequential is the gold standard. That's where every cylinder, if the firing order is 1, 3, 2, 4 on a 4-cylinder engine, the number 1 cylinder injector will fire at a precise time in the cycle of the engine. Then 180 degrees later, number 3, which is in firing order, then number 2, and then number 4. Each cylinder injector is addressed autonomously by the computer. It takes more computing power. It's more complicated to do that. Next, we have bank firing, which got started because of V engines. They would fire one bank and then the other bank. On an inline 4, they found they could do this by breaking up the firing order to like fire 1 and 3, then 1 full revolution, later fire 2 and 4, and then 1 and 3, 2 and 4. Better for emissions, better for mileage, better for power. Now, the low end price point way to do it is batch firing. That's where you just say, okay, a timing mark comes around, usually a Hall induction type switch of some type, and boom, I fire all 4 of them. Then the engine goes around twice and I fire them again at the same point. I just literally bloop, all 4, choo, choo, boop, all 4. This is simple, it's straightforward. It's definitely not the best for emissions, mileage, nor performance, but it will work. Ta-da! Okay, so that's your type. You should identify which type you have, realize the limitations of each. Now, these things are fired, and you have something called a fuel map. A fuel map is nothing but a computer lookup table. You have 2D maps, you have 3D maps. Over here I just quickly drew a sample little lookup table for a simple 2D entry-level fuel injection system. You have an alpha N lookup table, which is RPM on one axis, throttle position on the other. Manifold pressure is usually added into this as a trim. Now, how does this work? Well, let's say the RPM is 20% of the maximum revs of the engine. So let's say that's this line right here. And let's say throttle position is half throttle. So we would go halfway, come up, look in that block, and in that block will be a number. And that number will be the number of milliseconds to hold the injectors open. To flow more fuel, you make a bigger pulse. To flow less fuel, you narrow the pulse in milliseconds. Just that simple. That's the way it works. Wide pulse for power, narrow pulse for less flow. That's all the computer is doing, is controlling how long the injectors stay open and fuel flows. 3D map, alphanumeric plus manifold pressure, and what gives it the z-axis? Temperatures. Coolant temperature, air temperature, so on and so forth. With temperature, you get much finer control for emissions, power, and mileage. Now, there's one thing missing on motorcycles that cars have. And if we do this, this is an automobile. This is a motorcycle. Closed loop, open loop. These on motorcycle engines are open loop. It's not closed off to where we have feedback. What would close this loop? O2 sensors in the exhaust. Close that loop. That way the computer can do its best calculation of what the engine needs, verify it with an O2 sensor in the exhaust. If your motorcycle engine and system does not have an O2 sensor, put one in even though it's not incorporated with the computer. It is an invaluable tuning aid. And that's basically it for an overview for electronic fuel injections for FSA e-cars. And an intro to Ricky racers out there who've been with carburetors and now you have to deal with EFI. Go do your projects.